All right, so the spaghetti activity up here, all right, it's okay if you don't necessarily write anything down for here. Maybe you wrote down my numbers. That's fine. But let's test this out really fast. So again, let's always just focus on the two smaller sides. We're going to condense some work. But 6 and 8 are the smaller two sides. Let's add them together. That equals 14, which is bigger than the third remaining side, which is 10. All right, so according to our spaghetti activity, that's good. We get a triangle. Okay, again, let's focus on the two smaller sides. Sometimes they're listed first in numerical order, sometimes they're not. Just be careful, make sure you find the two smaller sides and compare it to the bigger side. So again, we get 2 plus 4, 6, bigger than the last side, 5. So it's good. We can make a triangle. All right, and then this one over here, we get 3 plus 5, which equals 8, which is less than 9. Bad. All right, it would collapse. It's like that last triangle I did in the spaghetti activity. They wouldn't be long enough to form a triangle. No trianguli. So the triangle inequality theorem states, to be more specific, the sum of any two sides of a triangle must be greater than the third. All right, we're going to be very thorough. However, the sum of any two sides is mainly smaller two sides. If it works for the smaller two sides, spoiler alert, it will work for any combination. So if we have some random triangle like this, and we have A, B, C, that means if I added A and B together, whatever those numbers were, it has to be bigger than C. What if I did B plus C? It has to be bigger than A. What if I did A plus C? It has to be bigger than B. All right, so any two sides, mainly the smaller two sides. If it works for the smaller two sides, it will work for any two sides. Add them together, greater than the third, triangle inequality theorem. Sweet. All right, so given two sides lengths are 6 and 2, the third length can't be larger than the two together. All right, which is 8. So we're at this problem right now. So say we know two side lengths are 6 and 2. Well, it can't be larger than 8 or we won't have a triangle. And it can't be shorter than 4. We won't have a triangle. All right, 8, whatever this number is, it has to be less than, let's write it like this, has to be less than 8. And then in this example, well, it has to be bigger than 4. Because if it's 8 or bigger, well, you can't make a triangle. If it's 4 or smaller, you can't make a triangle again. So what are the two inequalities for both solutions? Here, let's kind of rewrite it where we have x is less than 8, but also 4 is less than x. All right, and then we're going to bash these together and write it as a single compound inequality. So a compound inequality are just two inequalities in one. So basically this is saying if we know we have some triangle with side lengths 6 and 2, that means the third side has to be bigger than 4, has to be bigger than 8. That means the third side could be 5, it could be 6, it could be 4.123, it could be 7.999999999. It could be any of those numbers, all right? There's an infinite amount of choices. It just has to be between 4 and 8. And that's the triangle. That's a compound triangle inequality. So really, what we're going to be doing is we're going to be given two side lengths, and we got to determine the minimum x can be and the max x could be, the third side. All right, so given two sides of a triangle, write a compound inequality that represents the possible solutions of the missing side. So here, really, all you're going to do is, let me think about it. Let me think about how I want to write this. Well, we're just flat out write it out. You're going to subtract the numbers and x has to be bigger than those. So we can even write subtract. And use a little bit of logic. We want a positive number, so always do the bigger number minus the smallest number. And we're going to do plus, or addition, but plus is easier to write. We're going to do 10 plus 5. All right, so basically you're going to take the two numbers, subtract them. You're going to take the two numbers, add them, and that's going to tell you the range of values for x. So this means x could be 5.01, x could be 5.001, x could be 12.9, x could be 13, it could be 14, x could be anything in that range. All right, but this is the answer right here. This is what we're looking for. Similarly, in this next problem, it's what's the compounding inequality. You're just going to take the numbers 17 and 7, subtract them, put your x, and then add them. And it's going to tell us, it's going to tell us the range, where x would have to be bigger than 10, but less than 24. And just to emphasize things, hypothetically, if I pick a number less than 10, say I pick x equals 9, 7 plus 9 equals 16, less than 17, can't make a triangle. All right, the triangle inequality theorem fails, what we wrote previously. All right, so if you pick x equals 9 and for number 10, can't make a triangle. If you pick a number bigger than 10, like 11, can make one. If you picked 23, could make one. If you picked 24, you could not make one. All right, we even write that down. Pick x equals 24. We're going to get 7 plus 17, which equals 24, which equals 24. And again, it's not bigger. This would be a perfect line segment. Can't make triangle. All right, and then this last one over here, again, just subtract them. X has to be bigger than the subtraction, but less than the addition. Forget. X has to be between 1 and 11. All right, write three lengths that would be impossible to use for side lengths of a triangle. This is my favorite example. I'm gonna pick side 1, 1 in 1 million. All right, the triangle inequality theorem would fail. All right, 1 plus 1 equals 2. And to say 2 is bigger than a million, that right there is false. Wah, 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 wah. Cannot make a triangle. All right. Given two side lengths of a triangle, what's the largest perimeter you could create? Let's simplify this. We're going to say you can only use whole numbers, because again, we could use a lot of decimals and get really complicated and whatever. So here, all we got to do is to determine the largest. Well, what's 42 minus 15? That's not really going to be important in the long run, and we're going to do it anyways. All right, we're going to 27. X has to be bigger than 27, but less than 57. All right, so that means x, since I put the restriction, x can only be whole numbers, x is going to be 56. All right, you can make a triangle with 15, 42, and 56. So the perimeter is going to be 15 plus 42 plus 56. And we get 103. All right, similarly, one more problem. Again, we'll do practice writing compounding inequality, even though the minimum doesn't really matter, because we're looking for the largest perimeter. So x has to be greater than 16, but it has to be less than 50. Since we said whole numbers, the biggest number I can pick is 49. So the perimeter would be 17 plus 33 plus 49, which is going to equal 99. All right.